Hey, this is FlyWire on the Road, Sun and Fun 22. Today we're going to catch up with John Neilson of Flight Research. They're a major STC holder for MT props here in the United States for a whole bunch of different airframes. So stick with us on FlyWire. Hi, I'm Scott Perdue, and today on FlyWire we're going to talk to John Neilson of Flight Research. They sell MT props here in the U.S. We're going to talk about engineering, prop design, all that kind of stuff. So let's get to it. I'm here at Flight Resource. They're the guys that have, one of the main guys that has the distributorship for MT props here in the United States. This is John Neilson, longtime associate of, been involved in Flight Resource, which has now part of McFarland.
Loving it, yes.
Yeah, and so they have a bigger company and they're able to keep more props on hand and all that. So I thought I'd stop by and talk to John, because if you've watched my videos, you know that I'm an MT fan. I've had, I think I'm on my fourth, and I'm talking about buying another one here real soon.
Oh, I love it.
Yeah, so I really like MTs. I thought we'd drop by and we'd talk about how they make props, and we'll talk about that real quick. So,
fantastic.
John?
Good, fantastic.
Tell us a little bit about yourself. How'd you get involved in that?
I've been involved in aviation since I was about 8 years old. My grandfather flew a Cessna 140 until he was 87 years old.
Awesome.
I bought the plane from him, began flying it, and then began trading up to bigger and bigger airplanes, and until where I'm at now. And then my business partner, Larry Schlesinger, was one of the people who brought MT propellers to America for the first time. And he asked me if I wanted to be a partner in the business. And so that's how it started. That was like 15, 17 years ago. Long time ago. Anyway.
Yeah. Awesome. Well, great.
Yeah.
Well, again, I like elegance in design.
Yeah.
You know, I will admit that I use Apple products.
Yes.
It's an elegant design. Other things I'm not fond of, but it is. But this to me is a really elegant design. MT got their start in World War II, actually before World War II, but they were building props for the Germans, wood props. The British used wood props as well, but they weren't nearly as good as the Germans, and they ended up using metal props later in the war. But anyway, they got their start, and now it's a wood composite prop, and we're actually going to delve into this a little bit, and we're going to talk about it, and then we'll talk a little bit more about the propeller here in a second. So let's talk about how it's designed.
All right, we start off, we need to have a lot of strength right here in the root area. This is the important strength area that's going to carry a lot of the loads, the centrifugal force loads that are imparted on this propeller when it's in use. So we need a real strong material here to hold that in place. What MT has found is that the use of compressed beechwood is a way in which we can get a product which is stronger than a metal structure, and yet it is flexed. It has no stress risers. There's no life limits to wood, and that's the beauty of wood. It can flex indefinitely. You can damage it. It doesn't create a stress riser. Wood is elasticity. It goes back into its original condition.
And it doesn't have the voids that composites generally have.
That is very, very true. So what they start off with is beechwood, and think of it as like taking pressure treating lumber for your deck. The beechwood is injected, if you want to call it that, with an epoxy, and then 30% of its volume is then pressed out of it, physically pressed out of it, and it's allowed to cure under heat and that pressure until you end up with this solid block right here. So that's going to be our root area that is going to hold the blade into place and carry those loads that are centrifugal forces moving out. Now we got to get into lighter weight materials as we move out here. So in this section we're going to see the example here where we're now going to be transitioning from that beechwood into the spruce composite area that's left out here in the midsection.
And you can see this with the beechwood and laminate with the spruce, and it's very narrow at this time, so you have more beechwood.
Exactly.
So it's kind of like a finger joint.
Like a finger joint, yes.
Yeah.
Yep. And as we move out further into the midsection, now this is what you would be seeing right here, is you're going to have 100% of the spruce wood. And if we look closely here at the way in which these are laid out, the design of the MT is to provide multiple spars of carrying that load through that whole thing. So it isn't a single piece of wood. If your grandfather, great-grandfathers were carving out propellers, they bolt together a couple of 2x4s, and then shaved them out. we've gone way beyond that and created a composite block of multiple spars of specialty spruce that is interleaven with epoxy, and then that is shaped, and in order to keep this wood protected, we now put multiple layers of either fiberglass or carbon fiber jacket wrap around it. And then finally you put the leading edge on there, which is made of metal, either stainless steel or nickel.
Yeah. Well, real quick, before we start talking about the leading edge and the outside, I want to talk quickly about the grain.
Yeah.
And what's really important in wood is the width of the grain. And that's directly related to how fast the tree grows.
Exactly right.
And so grain that's really close together means it's actually taking longer to grow.
Yes.
And that's a good thing when you're building something like this where you need strength, because that makes it stronger. Nowadays, trees are a renewable resource.
Yes.
So building your houses out of trees, out of woods, and airplane propellers, that's a good thing because this is renewable resource. But the way trees grow nowadays, the way we harvest them and grow them, is they have very wide space grain.
Wide.
And that makes it very weak for these purposes. So one thing is I've really done a lot of interest, because I'm interested in manufacturing and stuff like that, is that compressed wood. The compressed wood is actually, they're developing that because it has a better, and again, it's been a long time since I've been in college and I studied this, so the terminology I believe is modulus of elasticity.
Exactly.
And that is directly related to the strength, but you get more of that out of a compressed wood like that beech wood than you do out of steel.
Out of steel, that is
And
exactly right.
that is fascinating,
Yeah.
and you don't have any of the
None of the downsides to it.
none of the downsides. Very fascinating stuff. So, okay, great. Well, let's talk about then the leading edge real quick, and let's talk about the
Okay.
outer covering.
After we've got the shape of the propeller blade is done by the CNC machine to shape it to any way we want. And then after that is done, then it's hand wrapped with multiple layers of carbon fiber or fiberglass as needed. And then those two elements are done to protect the wood core from moisture, give it some impact protection, and give it a little bit of stiffness too. We can add stiffness as desired throughout different sections of the blade by the placement and how the grain of that carbon fiber is laid down when it's put on here. So that's the last part. And then we put either stainless steel or a nickel leading edge on. The nickel leading edge that's used by MT is electroformed. It's not stamped, and it is electroformed. So it is grown in this shape, and it allows us then to have a very thick apex. The impact area here is 43 thousandths thick of nickel cobalt, and yet the end, where I've got the tape on here so you don't cut your fingers, is down to just a couple of mils.
Wow.
And we're able to totally encapsulate a cap on the end that provides protection all the way to the edge, and you can't do that by shaping and welding. It has to be electroformed to do that.
Wow, that's awesome. And I've had a stainless steel leading edge, and there's some abrasion and rocks do chip it, but this nickel version is pretty hard.
It's pretty hard. When we first got it out on these props right here, and we were using these propellers now in backcountry aircraft, it was a question. It says, well, how is it going to hold up to rocks compared to an aluminum propeller? Either of the stainless steel or the nickel is going to be harder than aluminum, and a rock hitting the front of this is going to be repelled. But I wanted to be a believer. So I took a sample of the MT propeller blade, just a section of it, and I brought it out to the airport. I live in a rural airport area, and I brought my .22 rifle along and set this up on a rock and held my .22 rifle with a barrel about 1.5 inches away from it, and I shot the edge of this with the rifle. This piece right here.
Yeah.
And it left a smudge mark on it. If you look carefully in the light, you can see the slightest indentation on there with a .22 long rifle bullet ricocheted right off of that, holding the barrel that far away. And then what I wanted to show then in the next one is that I then intentionally shot that .22 across the face of here to cause intentional damage to the blade,
right,
and then be able to show my customers then how they themselves are able to make those repairs using everyday two-part epoxy, saving a lot of money from having to go to a shop and things like that.
So what we see here is that in the thick part, it gave it a little bit of a dent, but then in the thin part, it actually did deform a little bit, but it didn't delaminate or break.
Exactly.
So you got some spalling as probably the ricochet shattered the bullet.
It just shattered, and
and kind of chewed it up a little bit. But yeah, I've actually had I had to do a repair to my Stearman MT, which is the old-fashioned,
Yep.
glue your laminate together and then carve it. It's actually a really good prop.
And it's a beautiful prop because they don't cover it with solid opaque
Yeah.
carbon fiber.
Yeah, it's like a piece of furniture, good furniture. So anyway, I damaged the face of the prop, which is the back. I damaged it with a rock, and what do? I got to send it to Florida? No, you just do this and that, and then a little bit of black spray paint, flat, and you don't even see it anymore.
That's right. That's
Yeah.
right. That's the beauty of wood. Is that you don't get worried. When you're building a house and you see your electrician and plumber drilling all kinds of holes
Yeah.
in the studs throughout your house. It doesn't weaken the wood. That does.
Yeah.
That's the beauty of using wood as your leading core material carrying the loads.
Cool. Well, I did want to talk a little bit about the actual design of the prop itself. And again, it's been a while since I've been in school, but I think the term is fine. It's called fineness ratio. It's the ratio between the length of the blade and its chord. Okay. So this varies quite a bit. It's very narrow here, and it's very narrow at the tip, but it's very thick. There's a wide chord here, just as the prop passes the right side of the fuselage.
Yes.
And what this does is this maximizes the thrust here, right by the fuselage where it doesn't interfere. So you don't waste compressed air from the prop going into the engine. There's enough in there to cool it.
Exactly.
Anyway.
It's like we're seeing here, like in these pictures here.
Yeah.
Wide areas, right? Yeah.
Wide area is right where it needs to be. You don't get much out of the trailing blade going this side. But so to me, this is an elegant design because what is really important for crews is the fineness ratio. So you look at some of the World War II props for like the B-26 in particular. The B-29 had very, very fine props, very thin chord, but very long. It was very good in cruise, lousy for takeoff and lousy for climb for those kind of props. So eventually, like in the P-47, had they call it toothpick blade.
Yes.
And they moved that to a paddle blade, and it totally changed the performance of the airplane because it's not cruise you want in a fighter.
No.
It's maneuverability and thrust.
Yep.
And that's what this gives you. You fool aerodynamics to think that it's a fine blade, a fineness ratio blade, because that's the average. But right here where you need it, it's a very wide chord. And I find that a very elegant design. I find it brilliant.
And the scimitar shape is another way of fooling the airflow. The air sees a longer wing than what is physically here because of the scimitar shape on it. And that's what we've been able to eke out just a little bit more efficiency on propellers that are built these days rather than the typical popsicle stick style was in the past.
Right. And the angle of attack changes throughout the blade's travel, throughout the blade here. And it's all pitched to maximize the effectivity of it. And even though this is a controllable pitch propeller, what you're doing is you're maintaining RPM, but the angle of attack for each part of this blade is fine-tuned, if you will, for where it is on this, what station it is out on the prop.
It's beautiful having the capability of being able to carve each blade to design. And when we're designing propeller blades for a specific application, the benefit and the luxury, the advantage that we have at MT is that they can design what they think might be the best for this particular application. We go out test fly it in various configurations, and then we can give them the feedback of what we found in that air, and just with a couple of key punch changes, they can give us new blades with just slightly different, maybe in one case we asked them that we think we need a little bit more twist in the outer 1/3 of the blade. A couple of key punch later, CNC machine puts one out, it's done. So development of new blades is very easy to do with MT using this type of structure. We also make the full composite blades, and those require a mold. So you have to really well define what you're going to have first before you spend the money to make that mold and make that full composite blade in there. But we make those as well. And MT also makes full aluminum blades too, so they know what they're doing.
They know what they're doing. Well, tell us, how do you get MT blades? They're not made here in the States.
Nope. The MT blades and the hub and everything is made in Germany. MT has been in production. There's now over 80,000 blades in production. Knocking on wood as we say it on here. Our STC props have never had an STC or an AD or an in-flight failure. They have no life limits. The hubs are a one-piece milled out instead of two-piece. So it's very easy to do overhauls, it's low cost to do overhauls, and whenever a person comes back from an overhaul, their prop is absolutely identical to a brand new one with the exception of the serial number on it. So it's a nice feature.
That's a nice feature. So how if somebody's interested in getting an MT prop, how do they go about doing that?
Depends on what you're going to use it for. One of the things that we can do at Flight Resource is that we do have the resources available and the connections with the factory that no matter what it is that you're flying, even if there is no STC for it, if you want an MT propeller, a custom-made propeller for your aircraft, that's something that we can do. Case in point, the twin Mustang that flew last time 2 years ago before COVID on here for the first time. There's only 2 in the whole world that are flying. And when those are being put back together, they needed props for them, which are just not available. The steel welded props are not available. They came to us and we designed and built the propellers, the hubs, the governors and accumulators to make those ships fly as exact replicas to the original welded steel propellers, and they're still flying today. Now, for regular production aircraft, we've made that real easy for you. You know, if you've got any of the Cessnas, Bonanzas, Cirrus, Huskies on here, all it takes is a phone call or an email on there. Tell us what you want. We keep them in stock, usually ship within 24 hours of funding.
Well, I hope you enjoyed this interview with John. We learned a lot about how the MT prop is made, especially that compressed beechwood in the base of the prop. That's fantastic. I love engineering like that. So I learned a lot. Hope you did too. Thanks for watching, and we'll see you next time on FlyWire.